Okay, today we're going to be looking at proof by induction, and this is new to the MEI specification for A-level further maths because it's divisibility. Previous years we've only had to deal with series and recurrence relations. This is divisibility. So we're going to prove by induction that this expression in terms of n is divisible by 12 for all positive integer n. Okay, so the expression here is 5 times 9 to the power n plus 3. And with all proof by induction, we're going to first of all prove it works with n equals 1. Okay, you're going to prove you can get on the ladder, and then you can prove you can get up the ladder. So we're going to get 5 times 9 plus 3. 5 times 9 is 45, plus 3 is 48. 48 divided by 12 is 4. Now that is an element of the positive integers, therefore it works for n equals 1. Okay, so that's true for n equals 1. Step 2. Now there are a variety of ways to execute step 2, but the way I would do it is I would break step 2 down into 3 sub-steps. First of all, I'm going to state my assumption. I will then put an I will show that, and finally a but. Okay, so I state my assumption, I state what I'm aiming towards, given the assumption is true, and then here would be algebra to show that these two are linked. So the assumption that I am stating is I'm assuming that 5 times 9 to the k plus 3 is divisible by 12 for some positive integer value k. Okay, I'm assuming that to be true. Given that assumption is true, I will show that 5 times 9 to the k plus 1 plus 3 is divisible by 12. Okay. Now, given that is true, if I prove that this is true, then that means that whatever value k is, the next integer value is true as well. And because it's true for n equals 1, then we've shown it's true for n equals 2, then it's true for n equals 3, and so on, in the way that proof by induction works. But 5 times 9 to the k plus 1 plus 3 is the same as writing 5 times 9 times 9 to the k plus 1 plus 3. Oh, sorry, not plus 1. So what I've done is I've taken one of the 9s out of the 9 to the power k plus 1. So I've got 9 to the k. And what I'm trying to do now is I'm trying to force my assumption expression out in the algebra so that I can use it. So in this case, I want a 5 times 9 to the k plus 3. So I'm going to take a 9 out as a factor there. And that's left me with 5 times 9 to the k. Okay, so I've taken the 9 out of this expression, this term. And if you take a 9 out of that term, that's going to leave me with a third, but I don't want a third. I want plus 3 still, because I still want this whole expression to be evident, which it is. But I need to correct that, so I've currently got plus 27, but I want plus 3, so I need to subtract 24 from that to make it true. Now, this term is exactly this, this expression is exactly the same as this expression. Now, by my assumption, this is divisible by 12. Okay, so I've used my assumption now. 24, well, that's divisible by 12. Okay, there we go. So they're both divisible by 12. And if you add two numbers together, or subtract two numbers in this case, that are both divisible by the same number, then the whole thing is divisible by that number. So because both of those terms are divisible by 12, then this whole thing is therefore divisible by 12. Okay. And then finally step 3. Just to summarise what you've done, you need to put step 3 in. I have shown it works for n equals 1, by assuming it works for n equals k, I have shown it works for n equals k plus 1. Therefore, it's true for all n elements of the positive integers by induction. Or something to that effect. And there will be a little QED at the bottom. Done.